Yeah. So, good afternoon, everyone. I'm Ayush Shukla, and my project is about inland navigability assessment of the Brahmaputra River. And some more background about me. So, I'm currently pursuing my bachelor's in engineering, particularly in electronics and instrumentation. So, by Brahmaputra. So, Brahmaputra is a is a very unique river, and it was declared as a national waterway in the 80s. So, it's a huge stretch of water. It's around 900 kilometers. It starts all the way from Sadia in east till Dhubri in west. So, it starts from the Myanmar, close to Myanmar border in the east region, all the way till Bangladesh border. Is on average throughout its length, it's around 5 kilometers wide. So it's very wide, and it's not a single channel. The entire river, it's the channel is very braided in nature. So the ships right now can't really navigate this corridor easily because of constant sedimentation. I mean, the river has the second highest sedimentation load in the entire world, and the discharge rate in the river is also pretty huge. It's the seventh largest discharge rate. It's the seventh largest river in the world by discharge rate, and the largest in India as well. So very tough to navigate for ships. So some sort of framework is needed which would unify sedimentation and the discharge rates and make something accessible for all the ships to navigate this river. So the main beneficiaries of this project, uh, firstly, the Inland Waterways Authority of India. So right now, what they do is to make the entire corridor navigable. They spend a lot of resources on dredging the river and make it navigable for ships without having a concrete idea on where to dredge and how much to dredge. So if there was some sort of framework that would help them to know ki, okay, these are the areas where the sedimentation load is high, so you need to dredge here. So something like that would help them. Apart from that, of course, the vessel operators that operate in the region, so they would help with some sort of map that would let them know that sandbars have shifted by this. So this would help them as well. Uh, Defense, search and rescue is also prone to flooding, especially during monsoon regions and the river in India. And does not use classical indices to differentiate water from land, since the water in Brahmaputra is very turbid. So we had to come up with our own indices to differentiate water and land. Also, we also make use of elevation derived bathymetry as one of our data points. I'll come to the methodology of how we are collecting data and where it is exactly being used. Also, this is one of our deliverables. We are delivering something called as a cost map for the Indian Waterway Authority of India. So I'll come to what this is in a moment. Uh, Providing some context, the work has been done in Europe and China as well, but we can't take their work directly for our purposes because their rivers aren't like Brahmaputra. The rivers are usually a single channel, and the discharge rate simply and the sedimentation load simply is not that much. So similar work has been done for inland waterways in other countries, but we can't just adapt it for our own purposes. So we had to somehow build a model on top of the work that has been done earlier. So coming to the methodology, so what essentially we are doing is we are dividing the entire river into grids. So the entire river is divided into grids, and since you are dividing the entire river into a grid, this is basically an occupancy grid. So each point on that grid has a certain cost attached to it. That cost is basically just a numerical analogy for how difficult it is for a ship to navigate on that point. So let's say the point is a vegetated island. So a ship can't go on that island. It has to flow on water. So the cost attached to that point would be 255, which is the maximum in an 8-bit system. And 0 essentially would indicate a very low cost. So that would be open waters. So essentially, we are delivering a cost map for the entire river. To develop these cost maps, we are using satellite data, particularly from Sentinel-2, and we are segmenting the entire river using image segmentation models into 5 different classes. The classes being open waters, shallow waters, mud flats, sand beds, and vegetation. So once we divide the entire river into these 5 classes, and also further then we use bathymetry data as well of the river. So combining these two data, we are abstracting away raw data into costs for each grid point. And now since we have cost, we can also provide route planning for our ships. So that is also within the scope of our project. We have also done route optimization for ships as well. This is some details about the image segmentation that we performed on satellite data. So as I mentioned, there were 5 classes and we used a UNet model to segment the data. And we ran multiple times to achieve the maximum accuracy. So the data set was manually annotated by myself to create different classes, and they were all auto-labeled data as well, which kind of used a refractive index of the light to differentiate between water and land. So that was the auto-labeled data. And so the best accuracy that we achieved was in run 3, when it was a mix of manually labeled annotations and auto-generated annotations. So just something about that. This is the result that we obtained. This is basically the segmented map. So you could see this is basically monsoon versus post-monsoon. So you can see how the channel changes from monsoon to post-monsoon. That is why the Brahmaputra requires studies across various times in the year, because a single study gets outdated very quickly in this region because of moving sandbars. So you can see not a lot of sandbars are there during monsoon period when the river is at its peak. But post monsoon on November, the river has kind of gotten milder, and you could see the braided nature of it is much more visible. So this was one of the outputs that we obtained. Yeah. So this is just our pipeline in pictures. So what we did, so this is particularly for the post-monsoon period. We did this and we did the entire thing for 3 cycles: pre-monsoon, monsoon, and post-monsoon. So this is for the monsoon cycle. So first we generated the segmentation map. So it has basically divided the entire river into these 5 classes. After we generated the cost map, so basically the red, it's a linear scale between green to red. So the red indicates high cost and green indicates low cost. So you could see the river channel being labeled as green. After that, the work is still pending there, but you could see the route is more or less taking through the braided natures of Brahmaputra, and it is still work in progress, but this will hopefully we'll get better results. So moving forward, so this is what we have done in this project. I've explained most of this already. Some future integrations that can be built on top of this project is instead of having fixed maps for different periods of the year, you could have some sort of live map that are constantly updated through satellite data. So you can use Sentinel-1, which provides you SAR data, and you can constantly poll the data from satellite and have a live map that updates constantly. And you could probably then use, publish this live to AIS of multiple ships. So this would provide as an aid to navigation for them. You could also build an autonomous vessel navigation stack. You can go into that as well. You'll have to install sensors on board and some sort of LiDAR sensors or stereo cameras, and you can do that as well. So this is an interesting prospect which can be looked into. This is also route planning. Once you go into local navigation, you can implement all sorts which would help the ship navigate locally instead of having just a global map.